Hi there. In this video, you and I are going to be looking at one of the many things that happens to light when it reaches the earth. You've obviously seen this happening before, and you've obviously made use of this once. This is Z Online School. In this video, you and I are going to be looking at an introduction to the reflection of light. We're going to do this in a systematic way, and if you've had any questions like what is reflection at plane mirrors, or how is reflection applied, this lesson is for you. At the end of this video, we've got bonus tips. Make sure you watch this video till the end to get the maximum value out of it. We're going to start with looking at the definition of reflection. Before we define reflection, I would like you to get to know that the word reflection comes from the word reflect. So if we know the definition of reflect, we can get the definition of reflection. To reflect, or the word reflect, means to throw back light, heat, sound, many other things from a surface. What you notice is that not only light can be reflected. Now, in this video, we're talking about reflection of light. So we're going to say reflection is the process by which light gets thrown back from a surface. Let's look at some examples of reflection for you to understand what we're really talking about. In the first picture here, we've got an electric bell. You can see this is not a mirror, but it's able to reflect some light here. This part here can't be seen properly. It's because there was a flash from the camera. In the second picture, we have a mirror. As you can see, the image formed here is much more clear than this one here. We have a bed here, and we have, I think, a window here. In this third image, we've got a nice curved mirror that gives us a nice large view. These three examples show us what reflection is. Reflection cannot only happen on objects like this. As you saw at the beginning of this video, you can even see a reflection in water. So everywhere you can see a reflection. At the end of this video, you get to even appreciate that reflection is something very important in our daily lives. Now let's talk about reflection at plane mirrors. Before we talk about reflection at plane mirrors, it's important for us to know what a plane mirror is. A plane mirror is a flat mirror that reflects light. One thing you should always note is that it's flat. There's no curve on this kind of mirror. If there's a simple curve inside or outside, the name changes. It's no longer a plane mirror. Later in other videos, we'll talk about those other kinds of mirrors and how they reflect light. These two pictures here show us an example of a plane mirror. As you can see, it's straight. If you've been asking yourself how mirrors are made, well, it's kind of simple to explain. I have never made one personally, but what happens is at the back of the mirror, there's a thin layer of metal. If you look in this mirror, this part of the mirror that's making us able to see something in it is the thin layer of metal behind it. Then, as you can see here on the side, we've got a glass after that thin layer. The layer is so thin you can't even see that there's actually a metal. It's time we looked at really how reflection at plane mirrors occurs. We have a mirror usually symbolized like this. The first thing you need to always remember about reflection is a special line that is perpendicular to the mirror. It's called the normal. Under reflection, we have a ray that's coming from the object that is going to hit the mirror. The point at which this ray hits the mirror is known as the point of incidence. After reflection, we're going to have a ray of light that is going to leave the mirror. These two rays have got scientific names. The first one, which is the ray coming from the object, is known as the incident ray, while the other one that leaves the mirror is known as the reflected ray. Obviously, you can guess why it's called reflected ray, because this is the ray that is a result of reflection, right? Now, apart from these three things we've mentioned and the point of incidence, we have other two things which are angles that you need to know. The first angle, which is the angle of incidence, this is the angle between the normal and the incident ray. Always remember that your angles are measured from the normal to the incident ray, or from the normal to the reflected ray. Never do we start measuring angles from the mirror to the incident ray. But don't forget that your examiner can make things difficult. Remember that we said the normal and the mirror at 90 degrees, right? So sometimes the examiner might give you the angle here and not give you the angle of incidence and ask you to find the angle of incidence. I guess that's some simple math. It will be just 90 minus the angle you are given here. Well, let's continue. We have the angle of reflection here. The angle of reflection is the angle between the normal and the reflected ray. These two angles might be symbolized by the letter I and R. What you notice is that R is also used for refraction. So how are you going to know this is reflection and refraction? Well, the diagrams do the talking. When you see something like this, we have a normal like this, and then a ray comes, hits a mirror, and then bounces back. You can see it's like you throw a ball here. It comes, hits the surface, and then bounces back. That's reflection. And so the R will be the angle of reflection. When we talk about refraction, you will be able to know how reflection and refraction differ in the terms of diagrams. I think this is quite enough for the illustration about reflection and plane mirrors. Let's look at some laws that hold whenever we have reflection. I hope you haven't forgotten we have this diagram here. The first law states that the angle of incidence and the angle of reflection will always be equal. If this law doesn't hold, you know that's not a reflection. If you find that the angle of incidence is bigger or maybe smaller than the angle of reflection, then you know it might not be even the angle of reflection you're looking at. The second law is that the incident ray, the normal, and the reflected ray are on the same plane. Obviously, this second law is quite difficult for some people to imagine. Obviously, you should understand that a plane is just a flat piece of land or maybe a flat piece of a surface. Most books would just say the explanation for this law is that it means the incident ray, the normal, and the reflected ray can be drawn on the same piece of paper. But sometimes I think you might think of it like this. If you get a plain piece of paper and you got a mirror and put it perpendicular to that piece of paper, any object you're going to put on that piece of paper is going to be able to be seen in that mirror. However, let's say you got an object and placed it above that plane. It won't be able to be seen in that mirror because it's not in the plane on which that mirror has been placed. With that said and done, now let's look at the properties of reflection at plane mirrors. There are 4 properties that are very important that you need to remember. I'm going to take a bit of a different approach in telling you the properties. I'm not going to just list them. I want you to understand what they really mean. Let's say we have an object like this. This is maybe a letter L on a paper. If you want, you can even get a piece of paper and pen, write the letter L, and then get that paper and try to see how it looks after a reflection. You're going to see that your L looks like something here. This is scientifically called lateral inversion. Our left part is on our right part, and our right part is on our left part. Now, let's say we had someone viewing this same letter L from another place, let's say here. It might mean this will get reflected at an angle. So we need some rays to be drawn from here that are going to likely be seen by this eye. Now we're going to draw some normals. If you can remember, the first law of reflection said that the angle of incidence should be equal to the angle of reflection. So we're just going to kind of measure the angle here for the incident ray, then draw the respective reflected rays. One thing you also notice that this object will look like it's coming from behind the mirror. So there are some lines that are projected to be imaginary behind this mirror. Obviously, this will be covered more in detail in a video about ray diagrams, but this is basically how the reflection will happen. Now, other two things you notice is that if you try to move this L a bit behind, you find that even the image inside the mirror gets further away. If you try to increase the size of this L, you also see that the image you see in the mirror becomes bigger. Those are the four properties kind of explained to you. In case you didn't take note, these are the four properties of reflection at a plane mirror. The first that you can remember is that the images formed by a mirror are virtual, which means the image cannot be formed on a screen. They are practically not real. This image we're seeing in the mirror is not coming from behind. If you were to try to go behind your mirror, you won't see any L shape there. Too bad if you try to do that. The next is that images formed by a mirror are laterally inverted. This just simply means that the left looks like the right in the mirror and the right looks like the left in the mirror. To prove this, just get that mirror and look at yourself. You see that your right hand will appear like the left hand of the image in the mirror. Obviously, these other two properties are not so difficult to understand. When you talk about object distance, we're just referring to the distance between the object and the mirror. And when we refer to image distance, we're talking about the distance between the image and the mirror. Obviously, we know that image is virtual. Now, when you talk about image size and object size, we're just talking about the actual sizes of these two. The size of the object is the object size, and the size of the image is the image size. These two will be equal, unless maybe you're using a mirror that is not a plane mirror. It has got some curvature on its surface and the rays are not reflecting in a straight way. Or your mirror has been made to perform some magnification. Now let's talk about how reflection is applied in our daily lives or in the science world. The first application of reflection that you will know or read about is the periscope. The periscope is a very useful device. Obviously, this diagram here is just kind of the shape of a periscope. We'll have this part here and another one here. On this part, we're going to have someone observing. One thing you should note is that a periscope is a device that can be used to see above obstacles. One of the most applicable places where the periscope is used is in the submarine. In the submarine, it's sometimes difficult to see what's happening at the sea level or at the surface of the water. So a periscope is put inside the submarine so that the people inside the submarine can see what's happening at the surface of the water. But you should note that they are still underwater. So how does the periscope work? Well, we know that it uses reflection because obviously in this video we're talking about reflection. In a periscope, there will be two reflective surfaces, let's say mirrors in this case. If we have an object, light rays from this object are going to travel, bounce, and then reach somewhere where this apple will be seen. This is how a periscope uses reflection for it to be used to see over obstacles. In actual submarines, these mirrors are replaced by prisms for a longer lasting. The next thing I want you to know about where reflection may sometimes be used is the microscope. Obviously, we're not talking about the latest microscopes. We're talking about those microscopes that were earlier made. Microscopes that used light. One thing you note about those microscopes is that they had a mirror, this apparatus here. This mirror simply just reflected light and made it possible for that light to pass through the slide which is on the stage. And after that light passes through, whatever is put on the slide to be observed can be seen better. In the latest microscopes, we're going to have an apparatus here that is producing light instead of relying on light that is found in the atmosphere here. This apparatus will even control the amount of light that will pass through the small hole that is found beneath the stage. We cannot exhaust all the applications of reflection. Obviously, there are many other things that involve the process of reflection. Here are more examples of the application of reflection. This is a mirror, obviously, that is used by females as they are preparing themselves. This here is a mirror again, used in shops. It's curved so it makes it possible for you to see a large view. As you can see, it's not a regular mirror. If it was a plain mirror, you couldn't see this much of an area. This mirror is usually used for security. We know that light travels in straight paths. Scientifically, that's called the rectilinear propagation of light. This mirror helps, obviously, the security to be able to see what's happening past a corner. In case someone is stealing, in case someone is trying to do something funny, they will be able to spot that. In the third picture here, we've got a wing mirror, which is sometimes called a side mirror, which makes it possible for a driver to see what's happening on their side. These three pictures are other forms in which reflection can be applied. You have finally reached the bonus tip section. In today's bonus tip section, we've got 3 tips for you. The first are the types of reflection. We have 2 types of reflection. The first one, which is specular or regular reflection. In this kind of reflection, we have a very smooth surface that can reflect things uniformly. If we have a beam of light that has been shined on a very smooth surface, we're going to have specular reflection. What that means is that if these rays are parallel like this, we know that these are incident rays, of course. Even the reflected rays are going to be parallel. If we change the angle of incidence, obviously because of the law of reflection, even the reflected rays are going to change accordingly. So this is the kind of reflection we're talking about when we refer to the reflection at plane mirrors. The next type is irregular reflection, which is also known as diffuse or scattered reflection. In this kind of reflection, we have a rough surface. Obviously, you might think for us to have irregular reflection, we need a very rough surface. But no, even things like cloths, papers, sometimes even walls are not smooth enough such that we can see our own reflection in them, meaning they are rough. In such a situation, if we have a parallel beam that is shined on this surface, even though the incident rays are parallel, it's not a guarantee that the reflected rays for each of these rays is going to be parallel. As you can see, the reflected rays are in different kinds of manners. This fits to be called scattered reflection. As you can see, still, even under scattered reflection, the laws of reflection still hold. If we were to change the angle of incidence as you saw, even the reflected rays are going to change their angles respectively. In the second tip, we're talking about reflection and its effect on color. In case you never knew, the color of an object depends on the light it reflects. Of course, you agree with me. In the first picture, we've got a red cap, black socks, and a white paper here. All these colors we're seeing are because of reflection. In this first image, the cap looks red because it reflects all red light. In this second image, the socks look black because they reflect no light. If you guessed that they reflect black light, well, now you know that for something to look black, it means it's reflecting no light. What about white? For white, it's the exact opposite of black. For this white paper to look white, it means that it's reflecting all light. I hope you can still remember that light is made up of 7 colors: red, orange, yellow, green, blue, indigo, and violet. These are some of the colors that can get reflected and can cause objects to look the way they look. One thing you should note is that all other colors that are not reflected are absorbed by the object, meaning this object absorbs all other colors except red, while black absorbs all the colors. That's why it looks black. White absorbs no colors, and that's why it looks white. In the third tip, we're trying to see if you have been quite observant. I hope you've seen an ambulance before. If you really took note, you will find that in front of the ambulance, the word ambulance is laterally inverted. Instead of being written in the proper way, it's like the person who was writing never knew how to write. But well, it's not that exactly. It's far beyond that. This word is inverted because usually when the ambulance is coming behind the car, the driver will look in his mirror. And when they look in the mirror and see this word ambulance, they are going to read it in the proper way. If you think that's a lie, pause the video and try to check this word on screen. You're going to see ambulance in your mirror. Thanks for reaching to the end of this video. Now it's your turn to go out in the world and keep observing the different kinds of reflections. Also, watch out for our next video that will be about more on reflection.